Hello. Oh no, my mic. Okay, it's fine. It's probably gonna be very echoey. It's an echoey room. There's like nothing in this room right now. I don't know where I should put it. I guess I should probably put it like over here. Also, the walls are very thin in this new place that I live in. And I feel bad about talking too loudly. I wish I had a mic arm. I should look into that. I feel like now that I've been streaming for long enough, I feel like maybe I'm allowed to want a mic arm. Wait, where am I? Let me get it. Where's my, what the, oh, it's over here. Here we go, there I am. Is this, oh, it's not on my clip. Where is it? Why is that there? Oh, okay, we're good. So we're here. It's dynamics time. Wait, why is that like slightly offset? Why are you? There we go. Is the bottom gonna be slightly offset now? I can't win, chat. That's fine, that should be fine. I need to use engineering paper. But we're fine, we got this. We're gonna be doing some dynamics, some motion, some I don't remember exactly, but we're gonna take a look. Let me see what the first, I'm so excited! It's dynamics! We love dynamics! Well, I didn't love dynamics. Dynamics was fine. I'm excited to get through this though, because I was like, well, also another good thing is she revised a problem, so apparently it wasn't right before. I started doing these problems in the airport when oh my gosh, hi, how's it going? What is this emote? They're little dudes. Scam? What am I scamming? I'm doing math, I swear, look, oh, it's so tiny. It's me, it's Damie. It's the real Damie. I'm not a fake Damie. Oh, let me move I have to like move my shit around here because I'm on like a smaller screen for my second monitor. I want to see you, chat. I want to see you bigger. I might have to, I'll try and change that. I've been trying to get everything set up in the past 20 minutes, so. That's me. That's Pino. Pino might get axed when I make the new emotes. I'm sorry, Pino. I feel like there's not a lot of situations where you want to use Pino. Except for, you know, Pino. Uh-oh. Is this like... Okay, no, we're good. It just feels weird to... Ooh, feels weird to... I haven't used my tablet yet right now. Okay. But we're good. I'll make 8. Let's do 8. I think 8 is generally... Yeah. Alright. At a given instant... Oh my gosh, we're getting back into it. Excited. Slider B moves at a constant speed of 1 meter per second. Okay, so we have the velocity of B. So, actually, okay, she has some, like, stuff that I have to do. Do not show more than one problem per page. Do not use the backside of engineering paper. Easy peasy. Include a given statement. Alright, well, so let's start with given, I guess. So we have VB equals, that's 1 meter per second. So I'll do this, 1 meter per second times, and then our vector. So we can split our vector into, I don't know, let's do, so it's negative sign 30, or let's do theta, let's call 30 theta. Theta equals 30. And then negative cosine theta, because our block is going that way. So that's our VB. Gotta put a vector hat on that. I only do integral students, my daddy. Well, it's okay, we don't have to even do integrals. This is less than integrals. This is like vector math, basically. Find the angular velocity and angular acceleration of link AB. Okay, angular velocity is gonna come first. So we know, I guess, that A is fixed. So we want to figure out, well, do I have to use a find statement? I think she says also say a find statement. Sure. I don't like given and find because it's like, just, I don't know, just get me into the solving. You're gonna define the variables anyway. We're trying to find, I guess, omega AB, which we can find with the relative velocity, and we want to find angular acceleration alpha AB. So we know that I'm gonna need to grab my where are they? Where are my in my equations that I don't have in my brain right now? There's the one I'm thinking about is the relative velocity one. It's like omega AB cross R, I think. Omega cross R. Sounds right, but let's check. Also, this is a little loud for me. I'm gonna turn it down. Let's see. We've got, yeah, velocity of point A in a circular path about point O is V is omega cross R. So now that would be the velocity of VAB, I guess. Like it's V, so solve, she said. So like V, B with respect to A equals omega AB cross RAB. It probably makes more sense to say that. Ooh. A huge eraser. What the hell was I erasing? It was so big. I think I know what I was erasing, but okay, BA. What do we think? What do we think, chat? Does that seem right? So RBA equals, what is it? It was 0.15 meters? And then times, we'll just do, let's see, so we're going to B with respect to A, so it's going to go from A to B. So we've got a positive Y, so sine 20 degrees. I guess I could call that theta too. Whatever, we'll live a little. So we're trying to find this, and then VB with respect to A. What else do I know about VB with respect to A? Let's see. VB with respect to A is like VB plus VA, because VA is not moving. So it's V. Wait a second. VB with respect to A, isn't that just VB? VB with respect. Wait. No, VB equals VA plus VB with respect to A. Yeah? Yeah? Because this is going from A to B. Wait, let me see. Isn't engineering really nice? For me, it's a perfect mix of all subjects. It is nice. I love your emotes. They're so hype. I feel like a lot of people discount the sort of English or like communication aspect of engineering, but I feel like that's also like a nice part of engineering. So VB equals VB with respect to A. So now we say VB equals, let's see, no, wait, we're chilling. We can just do the cross product out. Let me write this out. So this is gonna be 0, 0, negative WBA. Sorry, not W, omega. Ugh. And then RBA is, I mean, I can just do this. See, the funny thing I think about this class is it's like, oh, the big step up, 3D dynamics. And I'm like, well, I've been doing vectors like this the whole time, so it really doesn't matter if you put a number here or here for me. Like, it's still just the cross product. Like, we're not really doing anything different here. I guess I can low-key just put that in there too. It may be a little bit confusing what I'm doing. But like, who cares? I care, I'll fix it later. Famous last words. Wait, I need 0. We're in 3D. We're always in 3D, chat. Even if it seems like we're in 2D, we're always in 3D. Always do your cross products, always do all your stuff. Don't make any shortcuts. Negative cosine. Okay. And then 0, and then we just set everything. It's kind of easy peasy. I mean, until I get it wrong. You know. Hi Damie, bye Damie, I must flee, but hi, how's it going? I hope you're doing well. Okay. It's okay. I'm gonna use the power of you to get through this. What was I trying to find? I was trying to find angular acceleration, I think. Which means I'm gonna need to like do some lifting. Okay, let me think about this. It's been a while. So determinant, what's the best one to do a determinant on? I guess kind of just this one. Let's do that one. Chicken on screen. Oh my gosh, my chicken. My chicken. We're winning. So 0 minus, so that's gonna be positive sine 20 times WB, omega BA. I. Wait, I don't need to write I. I'm a big boy. And then 0, so that's 0. And then negative cosine 20. We did this one, now we're gonna do this one. That's negative J. Okay, the math, the mental math. Negative WBA times negative cosine 20 degrees, 0. If I get my signs mixed up, we know what happened. I'm losing my meters. Not a good idea. There we go. And then this equals... Wait, but I'm gonna get like 2 different answers. Uh-oh. Maybe it's okay. They might turn out to be the same thing, actually. I'm hoping. Okay, so W omega VA equals, I'm going to use this one, equals, what is that, negative cosine 30 over sine 20. Let's see. Where's my Where's my calculator? Oh, it's all the way over here. Wait, I gotta go run to get it. Wow. It's in my bag the whole time. Okay. Please, please, omega VA. Please be right, please be right. You gotta do a prayer before you try the calculation. Negative cosine 30 divided by sine 20. Okay, this looks kind of right. This looks kind of right, chat. Wait, this looks kind of right. Okay, let's see. She gave the answer. Fuck, it's not right. It's not right. Damn it, damn it. Counterclockwise, is that right? Counterclockwise would be negative... Wait. Okay, so I got the sign right. Oh wait, I didn't multiply by 0.15. Oh, shoot. Wait. No, it's so bad, that's so bad. Why is that so bad? What the heck? That's negative 16. Oh no, that is not right. Ooh. Yeah, that's not right. Okay, so we'll get there. Okay, where do I start even? Well, let's see if I do the other one. Wait, what if I like multiply by 0.15? That's gonna be worse. No, that's worse. Okay. Sometimes Sometimes you just gotta try. Okay, let's try negative sine 30. Hopefully it should give us the same answer. At least. Divided by cosine 20. Well, that was cosine 2, so not cosine 20. This is not the same answer. Okay, we did something wrong, for sure, Z's. What did we do wrong? I'm gonna guess we did this I did this cross product wrong. I think it only is supposed to have one WBA in it, which means that, because that would make sense, you know? Let's try and figure this out. So we'll get rid of all this. Alright, we're crossing this IJK, and then negative cosine 20, sine 20, 0. Alright. Let's maybe just do it, like, more thoroughly, so I don't have to, like, worry about it. So I'm gonna pick the top row. So we'll do 0 times 0. Minus sine 20 times negative WBA. And then for this row, but like it gives me another WBA or omega BA, and I don't like that. Like if you cross, let me think, you're crossing K with I and J. It kind of makes sense that it would be two dudes. But I don't like that, you know? Even. Ming and hawing. And the angular velocity and angular acceleration. Well, I need the angular velocity also to find the angular acceleration, so there's no point to just trying to skip it and come back. Let's see, what do we have here? Oh wait, she actually did an example, so let me see if... Where's this? Ew, I really hate given statements, I'm sorry. It's like, why are we doing this? Link AB connects everything together, general plane motion, VB equals VA plus VB with respect to A. Yeah, okay, we did that. VB with respect to A equals that. That was one of our equations. Expand each term of the equation. VB, sure. VA is something else. VB. Omega AB. Yeah, okay, no, so like I did it right. It's just like... I think it's just doing it. I probably just did some math wrong somewhere. So where did I do the math wrong then? Let's see. .15 meters. Maybe it's a negative issue? No, that shouldn't be a negative issue. Yeah, this is right. So it's omega AB sine 20. I switched it. It should be BA. And then you have... the middle one is 0, so this one is going to be positive, so negative omega BA. In the J direction. Maybe I'll just come back to this one after, because I don't really understand why. Wait. Oh yeah, times cosine, times negative cosine, so cosine 20. I was trying to figure out why I had an extra thing there. This one would be sine 20 over cosine, no, so cosine 30 over sine 20. 20, and then over, or 0.15 sine 20. That's not right. No, that's not right. Wait, maybe this divided by 0.15. Hey, wait a second, that's actually right. What was it, 3.5? Wait, okay, that's right. So this one is right for some reason, but this one is wrong. Why? The sine 30 divided by cos 20, but what if we get cos 30 divided by sine 20? And then divided by 0.15. That's super wrong. That's like uber wrong. So why? Why? It's still the same equation. Like, it should be right. Huh. I don't like that. One bit. Because if I do the negative sine 30 divided by cosine 20, and that divided by 0.15, that gives me negative 3.55, which is right. But why? Why? Should we do a cross product calculator just to check that? We can do that. Let's see. I feel like that, oops, that's like the best course of action. There's a chance that maybe VB... No, because VB is that, like, and we said that VB... Now the question is VB with respect to A? Because VA is 0, we know that. So then VB with respect to A would be just VB. Well, that makes sense. It's like, what do you add to VA to get to VB? You're just adding VB, right? Whatever it is. Okay, let's try this. Let's try the calculator here. So 0, oops. 0, 0, I'll just do X instead, and then negative cosine 20. Again, it doesn't really matter the numbers here, sine 20. And then 0. Alright. Cross product it up, let's see what it is. Negative sine 20x, negative cos 20x, 0. Negative sine 20x. Why? Why negative sine 20x? Oh, because... Oh my gosh, how's it going? Quinn, no way! It's because I put in the wrong sign. That's why it's wrong. Me, why is it not negative? Because I didn't put in the negative sign. Wait, did I just assume that it was negative? Why did I do that? Wait, why did I do that? What? Wait a second, why did I do that? That doesn't need to be there. That doesn't need to be there. I don't know why I did that. So they're both negative. Summoned by math, yes. Technically it's not math, it's more physics, but like, I stream in the math category, who cares? I'm doing some math. They're both negative. Is that right? Let me just like, brain it out here. Okay. We have, wait, why didn't I just use the WBA row? Wait, am I silly? Wait, guys, oh my god, it's been a long time since I've cross-product, apparently. That's so much faster. Let's be smartsies. Me, when I see a row with literally one thing, and then I go, oh, let me use the other rows with 2 things in it, and then why am I getting the wrong answer? I mean, I'm gonna probably get 2 things out of this, or it's gonna be wrong. Yeah, no, it's right. It's... Wait, maybe I pull out the WBA. Oh, wait, that's like what I needed to do. I needed to pull it out of both of them, and then... Is that right? Actually, fuck, I don't know. No, it shouldn't be. I don't want to think about it. Let me just do it like this. WBA. Sine 20. And then minus, so WBA, cos 20. Yeah, a 0. You assumed it was negative because this is a negative impact on your life. I think I just assumed it was negative because I was like, it's rotating negatively, so, but it's like, why would I do that? It's like, let me just change my light switch to like be on in the off position because I want it to be off right now. It's like, no, that's not how that works. Okay. But I still don't understand why one of these is working and one of these is not working. And I really don't like that quite a bit at all. That sounds like a bad thing to do. Because with this way, we get WBA equals negative cosine 30 divided by sine 20 times 0.1. That thing. We also, it's like we shouldn't have two of these. But if I have WBA times that, it's not like I can divide by a vector, lol. God, I'm so glad I'm not taking classes like this, as if my Anther major is gonna accomplish anything. I don't know, it's just like a fun pattern, it's like a fun game, you know? Not really that serious. Like, I'm just frolicking around with the numbers. But I don't understand why there's two. I don't like that there's two. It's frustrating me, and I feel like I had this issue before, but it's not really that easy to solve this issue because, like, I very distinctly remember having this exact kind of, like, oh, I'm getting two of my vectors and they're getting two different, you know, answers here, and one of them is the right answer and one of them is the wrong answer, and I don't know why. So like, I keep putting in cosine 30 divided by sine 20 and hoping that it's the right answer, and it's not the right answer. So, you know, I don't know why. Like, this gives me, oh, that's times divided by. This gives me 16.88. That's the face I'm making right now. And then the other one, which is nice and correct, it is sine 30 divided by cos 20, is 3.55. Are they like the same thing, but like the opposite things? You know what I mean? Like, but then, okay, we're gonna come back to that one. I'm gonna write a big note that says, why? That was the worst star in my life. Oh my god. Why? I drew this face like a million times during my thermal lecture. Guys, my thermal lectures. Look at all this space I'm not using on this paper. 16.88 frowny sad face. Okay, I can try and do the angular. No, I'm bored of this problem. Let's do another one. It's my toxic trait. Maybe we'll figure out how to do the angular velocity on this one. You know? This is, what is this, week 1. It was actually really funny though. She was like, oh, you can do problems 1 through 4 if you've taken dynamics before. And then I looked at the other two and it was like Euler's method, and I was like, oh, I did that in high school. We're chilling. Euler's method is not very hard to do. It's like a line. It's just like, what if everything was a line? Which I kind of like. I like being a line. Alright. Uh-oh, we got two things. Given. Ugh. Ugh. Oh, this is gross. Gross thing that I just wrote. Letter B moves down at a speed. Okay, so VB. At least I can write them as vectors. I got so much flack for writing them like this. But I don't know, it's like, if you're gonna do a cross product, you might as well write it like this. Awesome trait. That's so real. I don't know if that was in response to me saying I'm like a line, but... Oh, 2 meters per second? Oh, 2 meters per second. And then AA, AB, decreasing, so it's going up. Oh, they even drew it here. Bro, they're giving us a hint. Cool. Find the angular velocity and angular acceleration. Angular velocity and angular acceleration of link AB at this moment. Okay. Find. Why would I write find? It's literally written right here. It's not even hidden. Omega AB, alpha AB. Okay. Solve. Now that I've wasted some space. Actually, you know what? I can waste less space. I used to put my assumptions over on the right, and Hans Meyer didn't tell me off for it, so I'm gonna put my givens over on the right, and hopefully she doesn't tell me off for it. So wasting precious paper otherwise. Alright, so what do we start with? We know that VA is equal to VB plus VA with respect to B. And we know that this... What if I just like did it better? Is omega AB crossed with R, A with respect to B. I don't need to write two equations when I'm already gonna do that. Alright, so we need omega AB, and we're trying to find omega AB, so that's not gonna help us. But VA also equals... VO plus V omega AO crossed with... That's not really helpful. Watching the stream like Michael's Morales to get Peter Parker, I've been understanding nothing but sure am I here. I sure am here. It's okay, it's okay. We love that. Okay, this is a better one to start with. This one's gonna come later, I think. So I'm gonna put it like off over in the distance. Honestly, this is... Like, dynamics problems are kind of like Sudoku. It's like, you need to just find like a place to start, and then you kind of like worm your way in there, and you're just putting numbers in. Or at least these kind of dynamics problems. Like the linkages ones. But this class is like a lot about linkages, which I think is kind of interesting, because linkages aren't like that hard. They weren't the hardest dynamic stuff, in my opinion. Okay, now do I know what oh fuck, omega AO is? I don't think I do. I don't think I do. We're gonna need another equation. Do I know anything about omega AO? I know RAO, and I know the 45-degree angle. Oh. So we know a little bit about VA. Wait, yeah, of course we know about VA. VA is right here. Okay, we don't know omega AO. What do we know? What the hell? Well, we know, let's see, what do we know? We know this. We know this. We know this. But I don't know the angular velocity of AO. I know that VA is gonna be tangent, I guess. Maybe that'll help. But I kind of feel like it won't help. Because it's like the omega AO is gonna give us that angle. We just don't know what that magnitude is. Is there anything else, any other information that I have? Maybe there's something more about VB that we can extract. Is there there's gotta be something about that rotating speed of AO that we know that I'm like blanking out on here. Can I say VB with respect to O? They're not connected, but like, I mean, I guess I could, but then it would be like, oh, well, what's the omega of OB? That's not really helpful either. Let's see, I've got an omega. Yeah, that's so weird. What else do I have? Omega AO. I mean, I guess I can write it out as a vector, why not? like, we have, so what do we have? It's like 0, 0, omega AO crossed with RAO, which is 45, so cosine 45, sine 45, 0 times 0.05 meters. I definitely need to use this next. Because, like, okay, so we got VA, and there's something in there that we don't know. We don't know this. Maybe it's not moving? That's not, I can't just say that. What if it's not moving, guys? What if the whole thing just stopped moving? It's definitely gonna be moving. Okay, VA equals, let's see, VB we know. That's 0, -2, 0 meters per second. And this, we also know, is that cross, and then RAB is, okay, that's nice and easy, 0.1 meters. Okay, so now that didn't really get me anywhere. There's gotta be something else in my back pocket that I can use. So right now I have relative velocity and I have that circular motion thing. I'm using the circular motion already to define A twice. But there's gotta be some other thing. It's gotta be. Arg, my eyes bleed. It is written math and I see physics. I'm sorry, Storm. I know it's not math. It's kind of math. It's vectors. It's cross products. There's not really a physics category. How am I? I'm good. I finished my move. Still kind of unpacking, but I'm just like doing all my classes. I have a 6 to 7 p.m. thermodynamics class, which is kind of rough. But why can I not figure this out? What is happening? We know VO. Can I just say, like, I don't know the angular speed of OA. What? Awesome, good luck, thank you. Is your research going well? No, I was gonna say, does AB undergo, no, it doesn't, it undergoes general plane motion, it's moving and translating at the same time. What the heck? Is there, I'm definitely missing something. 2 equations and technically like 3 unknowns, because VA, but I'm gonna set these equal to each other. 1 equation and 2 unknowns is not enough. That'll be something. I related A to B and A to O. O to B, I guess, like, if I say B, but that just gives us the rotation of that, which is not really helpful. My subjects now are darker than ever. I currently study category theory and Riemannian geometry. That's really cool. Wait, that's awesome. Sorry, I'm gonna quickly see if she like did this out. Oh, my music just like decided to stop playing. That's fun. Oh. Let me see. So yeah, she's just doing the cross products. Which is exactly what I'm doing. Oh wait a second. Oh, VB is relative VA plus V. Let's see. Instead of doing V, she replaced VA with... Wait, but I was just about to do that. I was just gonna replace it with this. It still doesn't fix the fact that I don't know. Category theory is abstraction at its peak. Well, give me an intro to it. What do you start with? This is a very similar problem. Let's see how she does the... VB is known, VA is AC. Sure, the center. Oh. Oh! No, I know why, I know, we're chilling. It's gonna end up in 2 different places. Oh shit, I forgot about that. That's how vectors work, lol. Okay, it might work out, let's try. I forgot, oh my gosh, chat, I'm so silly. It might not work out right, because now that I'm looking at it, I'm seeing, actually, wait a second, no, because this is only 1, so that actually might work out. Oh, oh. Wait, we might be cooking. Wait, we might be cooking, wait a second. Okay. What is this? This is meters per second. I don't really need this. I don't want to put these on here. This feels like I'm gonna mess up some units. I hope Storm gives an awesome explanation of category theory, because I would love to hear about it. Alright, so we have, if I do this and this, we have, let's see, omega AO sine 45 minus omega AO cosine 45. I really shouldn't leave that on there. Ooh, okay. We start by defining what a category is. It is the information of ob and more, where ob C are all the objects in your category C, and more are all the morphismy between your objects. For example, the category of sets, object of sets is all sets. More set is all applications between sets. Ooh. So what is a more? Like, more specifically. More specifically. That was a bad one. I don't know, chat. I'm a little worried about this, but I think we're gonna get one equation where this works out. So this is gonna be 0i and 0.1j. Yeah, we're chilling. Okay, yes, I remember this. Uh-oh. No, wait, we're not chilling, chat. It's 0. Wait, WAO is 0? It doesn't move? That's not right. That's not right. Oh, no. Wait, what does this mean? This means 2 equals 0.1 WAB? Wait a second. Wait, that's actually right. Wait, stop. How is that right? It doesn't turn? Oh my, I mean, okay. What is this, rod per second? Hey, that's right. I'll take it. Okay, so I don't suck. I don't know what the other problem is. Counterclockwise. It's negative? Wait a second, that's not right. It shouldn't be negative. Right? It should be positive. Let's see. And after this, you can study the applications between categories, and in particular the application which keeps the structure of your category, because these types of applications you could send a result from a category to another category. Oh, that sounds really cool. So it's like an interconnected like system. Where's all the morphism between objects? To explain it another way, if you make a diagram where you put a point for every object, then the arrows between the point are the morphism. Okay. So, but like, is it just like a relationship between objects, or is it like, are you doing something to the objects? Okay, where's my flipped up sign here? The flipped up sign is either the -2, which is not correct, or this other one, which... Oh, it's the middle. So it, actually, no, that should be positive. Because I'm using that row, so it goes positive, negative, positive. Right? Wait, no, maybe that one's negative, positive, negative, and I'm just goofed. I'm gonna check the cross product calculator, because it's been a bit. Sorry, guys. Sorry, gamers. Me and I can't do a sign. What am I crossing? I already forgot. 0, 0, x, and then 0.1. It's gonna be like, yeah, you dumb motherfucker. No, it's positive. Oh, it is positive. Wait, what? Wait. Yes, because it's negative. It's negative, and then you have the 0.1, which is the... Sorry, I'm trying to do some of it in my head. I used to be pretty fast at it. It's really the study of the structure when you look at the relation and all the objects at the same time. Oh, I see. So, is it like... Is it like data science-y? Or like what are... I mean, I guess it's relationships. I don't really understand like what an example of a relationship between objects would be, I guess. Is my first question. Like maybe an example would kind of help me out there. Okay, should I just do all the velocity stuff first and then come back and do the acceleration? Or I just did this one, so maybe I should just do the... I know the acceleration takes a lot longer is the thing. Let's maybe do that. Let me start with all this. This is due Monday, so we should actually be okay on... Oh, whoa. Oh, this one's cool. I remember looking at this one. Got a little bit spoiled, but... I'm gonna put it here. Alright. Semicircular disk has a radius of 0.4. At one instant when theta... Okay, our theta is... Oh, I remember Lightsel gave a problem like this. My other dynamics... My dynamics professor, not my intermediate dynamics. Okay. So we have theta... It's just like a really annoying geometry problem. It is rotating counterclockwise at... omega equals 4. Which is increasing in the same direction. Okay, so we're given... Let's just say omega O equals 4. Counterclockwise is positive. And then we've got alpha O equals increasing, so 1. Find the velocity and acceleration of point B at this instant. Alright, I like how the B is not even a point. Let's do that. Ooh, okay, we got some wacky numbers there. Example, ooh, okay, here we go. If we write top, the category of topological space with morphisms which are continuous map, and set, the category of set with morphisms, all of the applications between them, then a good application between these categories is f of x tau to x, and f of f equals f, where tau is the topology on x. Here's this application is called the forgetful function because it just gives the same object, but you forget the topology and the fact that f was continuous. That seems very very like, it kind of feels to me like programming in assembly. You know, it's like, it's so low level. It's super interesting, but it's like you're going down to like all these little bits and details, which is really cool. What do we need? We want VB AB. Sorry. Whenever I write like a little smiley face, I'm always like, oh, is this professor gonna like it? Nobody ever dislikes little smiley faces. Currently, it blows my mind. It's blowing my mind. I don't really know what most of that was. But like, how, so you just forget it, so you put it into the function and you remember it? Like, what does it give it back? What's the function? Like, did you just make a function up that just says like, yeah, it gives you the, think. Okay, so we kind of need to figure out the speed of O, I think, and then O, so A is our VA. Well, okay, low-key, I'm gonna just say VA equals 0 right now. Wait, I need to use engineering lettering, sorry. At this time. Alright, so we can say VO equals VA plus VR, wait, VO with respect to A, which is omega O cross, okay, this is good, omega O cross R, O with respect to A. This is 0. This is geometry. Wait, no, it's not geometry, it's 0.4. Let's go, baby! Let's go! Sorry, I got too excited there. Equals, what is that? Should I just set up the... Nope, I'm gonna do it out, 0, 0, 4 crossed with... No, I'm gonna do it. I'm gonna be a rebel. I'm gonna do this. 0, 0, 4. And then ROA is 0.4. I'm gonna take it out. It's just going up. Because it's right there. Isn't that nice? Is that true for every point? I guess the contact point is always directly below the center of the circle. Interesting. So 1, 0, 0, and then we multiply that. I don't like saying times that. We multiply that by 0.4 inches. My professor began the course on it by this sentence. Some mathematicians say that it is useless and something it is an obligation to know, so make your point. Some think it is an obligation to know, so make your own point of view. That's really funny. I feel like you could say that about so much stuff. Now, the previous F is what we call a functor. Oh, not a function. It's an application between categories which keeps the structure. So if you add two objects A and B, and an arrow F from A to B, then F of F will be an arrow from F of A to F of B, so you do not always have an inverse. Ah, okay. I think I see. Isn't... so... is that at all like graph theory? That feels almost like graph theory. But graph theory doesn't really have the same thing where there's like a directional connection. You know, it's more like, oh, we have like a connection between 2 points, and then we're trying to traverse to a point, from a point to another point. What was I doing? Okay, that's VO, so that's defined. VO is good. Wait, I'm straight up just trying to find the velocity of B? Easy peasy. Oh, maybe not. Equals what? VO plus VB with respect to O, which I'm gonna say omega O cross... yeah, this is not even that bad. Wait, not O. VC. What was it called? VO? No. Oh, it is called VO. Well, I thought it was A. And we have VO, that's known. For example, the previous F is not an inverse because when... what does that say? When I have X, I can put several topologies on it. Ah, yeah, it's a link to graph theory. It's a generalization. Okay. I think I get it more now. Because I was trying to think of like, how is that related to like functions, but it's more like a spatial math then. What am I doing? VO is known, this is known, and this is known. Okay, easy peasy. I guess I should probably like do this out. Let's get what VO is before I do that. Okay, now it's coming back to me. This is all like the easy part of dynamics though. The hard part is like the moment of inertia stuff. Like any energy stuff I think is harder than this just as like relative velocities. Okay, if we do the 4, we're gonna get 0. Is it just positive 4? Wait, sorry. 0 minus 1, but it's minus 4. So 4j. Well, times 0.4. So it is 4 times 0. Well, that's 1.6. It's really the more abstract way to look at math. You look at the structure of different fields of math independently and you try to find the same structure between different fields. Oh, wait, that's so dope. Oh, that's actually really cool. So, okay, it's like the study of the study, almost. And then RBO. Well, that's this. That's what they give us this angle for. Which is, I don't know, 0.4 times... God damn it, I didn't write it out. Let's see, cosine, negative cosine. What did it say? 30, 60, 60. And then times 0.4, so we can just pull the 0.4 out. BB equals 0, 1.60 plus IJK 004 negative cosine 60 sine 60 0 times 0.4. Yeah, exactly, but in fact, it is a powerful tool to prove some theorems. So wait, so are you trying to research this, or are you just kind of learning the stuff before you do the research right now? Plus, I don't know what this is. Let's do this one. So, it's not really that bad. 4, so 1.6 sine 60, negative, and then positive 1.6 cos 60 equals, I'm hoping this is right, 1.6 sine 60, 1.38? That does not sound right, like what they got. Nope, that is not what they got. It is negative though, so 1... Maybe I'm missing a something or other. 1.38, 1.39, and then this one is 1.6 plus, whoops, plus 1.6 cos 60. 2.4? Does that also make sense? Let's see, I said that it was going, that would be going up. What? It's wrote in counter, oh yeah, there's something messed up in here. Something sign-wise is goofy. And 0.8? Okay, so that's not right, but we'll get there. Wait, because when you keep a structure, you know that your property at the beginning are conserved under F. My last topic before my internship before the PhD. Oh, if all goes well, I'll do some knot theory and low-dimensional topology. Oh, that sounds awesome. Wait, knot theory is so cool. I really want to learn, it's not really in a math sense, but I want to learn some knots, like decorative knots, because I started doing some knot tying stuff, and it was really fun. It's really hard though, because I was just using whatever string, and it kind of turns out that if you just use whatever string, it doesn't really work too well. Not really anything to do with math, but yeah. Alright, let's see. Where am I? This is going really wrong, but I don't know really why. It could be anywhere, to be honest. But that is often the case. Yeah, if I do this one, so this is positive, negative, positive, for sure, positive. Or J. 4 times 0.4, let's just check that. 1.6, good, I can still multiply two numbers pretty easy. Yeah, what's fun is when you want to describe a knot as a topological space. Ooh, yes, that does sound fun. It sounds really fun. I'm not even like being facetious. Alright, let's see. So VO. Does that feel right? This is what this is saying is VO is only moving sideways, which, knowing what we know about a circle, yes. That makes sense. But actually, if it's rotating counterclockwise, wouldn't it be going to the left? O should not be moving this way. O should be moving this way. Right? So what's up with that? Yeah. ROA is right, but why is it? That's a little, I don't like that. Like omega is positive, but that means that VO, it should end up negative. Right? Am I goofing up? Am I doing like the sin where I cross product backwards? I hope not. I don't think I am. It's rotating counterclockwise, yeah. Example of just the no knot. It can be seen as 0, 1, where A might be if, whoa. Or more simply, it is S1. What is S1? A subspace? Or a set? me thinking of linear, a subspace. I mean, it could be anything. It could be like swag awesome. Oh, it's just the circle? Oh, it's just called that. Okay. mu and the circle. No, I'm doing the... What the hell? It's supposed to be negative, though. Like, in my mind, I know that if it's rotating this way, O is gonna move to the left. So why is it going to the right now? Hello? Hello? Can I just, like, say that O is going to the left? Also, she said just memorize this, so maybe I should just, I mean, it's omega r, but, like, you know, it's the first problem set. You kind of want to... Well, okay, so this is negative, and this is negative, and this becomes negative. And then if I do this one, then this would be positive, and this would be negative, which would certainly change the magnitude of this one. 1.6 cosine 60 minus... Uh-oh. Wait, what? Ah, that's 0.8. 1.6 cosine 60 is 0.8. Which means that maybe it should be 1.6 plus... I might have gotten mine flipped. $2.9? Wasn't the answer 2.9 something? Ah, okay. So there's I don't think she got it wrong. But this is weird because mine is flipped. My directions are flipped. This one is right. No. The 2.8 needs to be here? Wait, what did I just do? I just did sine 60. Wait, this should be flipped. This should be here. Oh wait, it should be there. What am I doing? Wait a second. Wait, what? Wait, whoa. Oh, it's because the 1 isn't here, the 1 is here. Oh, chat, I said the circle was over here. Oh, shit. Okay, yeah, so that's negative, so that's why this is negative. And this becomes negative 4i. There we go. Okay, the math wouldn't do me wrong. It was just... To be fair, I didn't even get my cross product wrong. It was just, I literally set it up wrong, so... And this is negative 1.6, 0... Negative 1.6, 0... This stays the same. We'll check these signs real quick. And then I'm gonna read your thing, Storm, I swear. Okay, for, let's see, positive, negative, so this one is going to be negative, so when we do this, it's negative this and positive that. Wait, negative, wait, shit, because this is negative, no, it's going to be another negative. I think they're both negative. I'll go to sleep, have a good night, and good luck. Oh, thank you! Okay, S1 is xy belongs to r squared. Oh yeah. Sn such that, okay, yeah, so it's like a sphere. Sn is the hypersphere of dimension n. Oh, that's cool. Yeah, there was a lecture that I wanted to go to on like the sphere in like 4 space or something. I don't remember exactly what it was, but I didn't make it, so that's why I don't remember it. I didn't get to go, Sag. Yeah, today might also be a shorter stream, just because I was fiddling with stuff. But it kind of depends. I want to keep trucking on this, because I have to get this done also, so, you know, it's like for me, you know. Alright. So negative, this one should be negative, so negative 1.6 sine 60. No, okay, please be right. Please be right. Fuck, that's not right. Oh, wait. Minus 1.6? Okay, good. That is right. I was so worried. I was like, bruh. Negative 1.98. Wait, 985. Wait, what? No, 2.98. 985. Germa 985. No way, he's in my math problem. I'm gonna say 99. Is that good enough? 8.5 is basically 9, yeah. And then the other one is 1.6 cos 60. Cos is negative 0.8. Who's the best? I am. I'm really not. Equals VB. So yeah, we'll do all the angular accelerations later because they're basically just this, but like twice the work. My old dynamics teacher, she was like, so yeah, you know, get your omegas, get all that stuff, easy peasy, and then once you get to your alphas, then it's gonna take a while. So that's not even just anecdotal, that's just like how it is, truly. Honestly, I'm pretty happy with how much I remember after like a year of, not a year, half a year of not doing this. So I'm feeling pretty good. Oh, I had such an embarrassing moment. She was like asking about this rotating disc, and she was like, what motion is this undergoing? And I said rotation, because if you think about it like a rotating disc, this point is just rotating, because this has a velocity of 0 at that point in time. So it's kind of like it's rotating and then it moves to the next point. She was like, no, it's general plane motion because it's moving at the same time. I'm like, I understand it's moving at the same time, please. I swear I don't think the sphere is like nailed to the ground. Please. It's okay, I'm just like a weirdo in class. She also asked, like, we were doing polar, and she was like, okay, so can anybody tell me why the velocity is not tangent to the path? And I was like, because that's not the path. Because the path of this, like, if it flies out this way, but like it's on an arm, right? She's like, why is it not tangent to the path? And I was like, it's not on the path. And she's like, well, yeah, that's the simple answer. So like, what is the path? I'm like, that's what you asked. You didn't ask for what the path was. And somebody's like, a spiral. And she's like, oh my gosh, yes, you're right. And I'm like, please, please. Okay, refer to B, get out of here, A. The disk OA is rolling with no slip at constant angular velocity, omega. Find the angular velocity and angular acceleration of link AB and link BC and BC. Okay. So given. Ugh. Can I go back to Hans? I'm miswriting assumptions instead of givens. Okay. Angular velocity, what is this? Well, omega equals omega. Well, I mean, I guess I can say omega OA equals omega OA. Usually, I try to call it O if it's a circle. And then, I mean, I guess we can say clockwise, which is actually kind of important. Oh wait, actually, wait a second. We can do this. Let's do this instead. 0, 0, negative omega O. I like that. And then, what else do we have? We have angular velocity and angular acceleration. Yeah. Alpha O. Find alpha. Find omega AB. Omega AC. Alpha AB. Alpha AC. Okay. Okay, chat. Where do we start? Let's start with locating point A. Is that right? I mean, we could just jump. We could do jumpy jump, but I kind of don't like jumpy jump. I like, because she was doing jumpy jump, and I like to be a little bit more thorough. But we know that VA equals, I mean, I could do this. I'll just do this. Omega O cross. I'm gonna do this because it's important to me. I like showing what I'm doing. I don't like being like, oh, it's just, oh, you know, it's just that. We know what it is. It's that. I need to close this window real quick because the sun is directly in my eyes. I was having this issue yesterday and I was like, I just don't want to work because the sun is like right in my eyes. It's still kind of right in my eyes. It's like reflecting off of my... It's getting so dark in here. Oh my god, how is it still in my... Bro, my shade is closed and it's still in my eyes. No, that's the other way. The other way. Okay, that didn't really help. I mean, it helped a little bit. Maybe I can go up. Maybe I can direct it up instead. We're trying. We're engineering. Ah, there we go. Easy, easy. Alright. So, what was I doing? I forgot. Oh yeah, we got VA. There's a big tree near my window, so it kind of like dances around the light. VA also equals... What else is VA equal? It equals VB. I'd rather say VB equals VA, because we know these two things. Yeah, let's actually wait. Let's define that out, because we actually know those things. So it's gonna be IJK 0, 0, negative O. And then the radius is gonna be 0 R 0. Cause, oh dude, oh. Let's do that. Oh, and that's also a determinant, not a vector, not a matrix. Alright, this is gonna be negative here. So it'll be negative, or it'll be positive WO, which makes sense. Yeah? Yeah. She said memorize it. I mean, it doesn't feel... It feels weird to memorize it. Like, I mean, I guess I could just say it is that, but it's like, how do you know that I know that it's that? How do you know I didn't just look it up? What do you want from me? They don't want anything from me. They want the answer from me. They want the process. They want the process and the answer. Alright. Yeah, VA plus mega AB, which is what we like, plus R, cross R, B with respect to A. Nice. Chat. You know what was funny is I was literally just thinking, wow, it's really awesome that that thing didn't happen. Like, it just didn't, you know, it didn't happen. And it's, like, fixed. And then... I tried. I really tried. We'll figure it out, still. Anyway. This one I want, so we need to define VB as another thing, which is... And then we just have to, yeah, we basically just have to, like, not pray, because they are going to work out, but we have to hope that the cross products work out. So basically we do... I already showed that it's, that this is the way that you do this, so I feel like I'm allowed to do this. Now the only thing about this cross product is that E to C goes negative, so instead of here, this would be -1. This is gonna be negative U, CB, R, 0, 0, instead of positive. Because, it goes negative. I believe it does, I don't know. I could be wrong. But I think we're good. If our signs mess up, then we know. I'm gonna put a little star here and say negative. Alright, then we just have to say these say these are equal to each other. Omega CBR equals Omega OR. I like that. Plus Omega, oops, I, J, A. Oh, I probably should do that first, huh? Maybe. Nah. I'm just gonna assume it's positive, and then... Okay, R, let's see, B with respect to A is 2R, so it's, 2R. Cool. So we got, what do we have? Negative omega CB times R, 0, 0. Equals omega O times R. I guess I can factor out an R for everything, huh? I feel like that's wrong, but we're just gonna keep going with it right now. What, just omega AB times 2R? Fuck, wait, that's not right. Is it? No, damn it, our cross products didn't work out. Shit, okay. I mean, it's an equation, but I don't know if it's right. Wait, that's J. Oh, they did work out. Whew. 0. Oh, shit. 0, W, omega AB. What music is playing that I cannot hear it at all? Let me get out of this. Weird. Oh, because my sound is off. What? There we go. But also, it's very loud over here. There we go. Alright, so now, WAB equals 0. Oh, it does equal 0. Pog, let's go, chat. We're winning. WAB equals 0. Woo! Yes. Oh, yes. Very excited about that. Very, very excited. First try. And then WBC is going to equal, or CB in my terms, is going to equal, omega? Negative. There's a 2 in there. Uh-oh, that feels weird. But we're close. Did I drop a 2? I dropped a 2 here. That should be that. Why would there be a 2 in there? I don't like that there's a 2. The radii cancel out. Wait, also I forgot the R. I got too excited. Where would that 2 come from? Because, I mean, it's not like BC has a 2 in it. Right? What am I missing? What am I missing here? VA, let's see, VA is this, that's gonna be R, that's right. VB is also just R. Where? Sorry, enough noises. Where's the 2 coming from? Hello? Did I do that? Well, they're like all not affecting each other, so it's not like I can have a 2 in that other cross product. The negative is right though. Well, I guess it wouldn't really matter if the negative was right or wrong. But I think it is right. Oh no, it's not right? I guess it's not right. That's weird, because it would be -1 there. A positive, negative, oh! No, that's right, because this is the second one. Why is it not negative? Wait, what? What's happening? I don't like it, Well, we're gonna finish it later. That's how we do it here. Got scared that my mic exploded for a second there. Did not. Oh yeah, this is easy. Okay, I think I can do this. We can attempt to do this. I believe I remember. They say hand calcs, which is actually nicer than doing it in MATLAB right now, but. Okay, so an air bubble breaks loose from the bottom of a water dish and rises to the surface. Based on a Newton's second law analysis, it has an acceleration of this. I guess it's not really, it's just that v, where a is in feet per second squared, the position x, use Euler's method with hand calculations to find the position, velocity, and position after the first 2 time steps. Okay, so do we have an initial, wait, do we have an initial condition here? I guess v would start at 0. Maybe I don't know how to do this. Let's see. I guess x is 0. Can I take the derivative? Well, I know that... Fascinating. Do we assume that v equals 0 at the beginning? Ooh. I'm gonna read over her notes real quick. Because I've done Eulers, but I don't necessarily know how to do it for... Oh, whoops, here. For... numerical methods. Eulers is like you take the slope. Oh, I get... Well, yeah, I guess you would just take the slope of this then. Let's see. Analytical... numerical methods, Eulers. Consider a second order differential equation. Solve velocity by taking initial velocity. We're not given the initial velocity. Yes, I know that. I know that that's how you do Eulers, but it's not giving us the initial. What? Bruh. Bruh. Babe, please. Okay, this is just saying like how to write a for loop. Okay, I'm kidding, it's not doing that. It's doing a little bit more than that, but it's basically just for loop. Solve displacement by taking initial displacement and then using the slope to find the next displacement. dv dt acceleration equals 3 over v. Oh, okay, so solve velocity by taking initial velocity and using slope to find next velocity. Well, let's just assume that v0 equals 0, x0 equals 0. Which means that a0 equals 0. No. a0 equals 80. So, sure, find, like, what is it? Velocity and position, x1, x2, v1, v2. We'll just try and do it this way. Basically, what we have to say is we take our v0 equals 0, and then we take the slope of this line at 0, which is, what is it? Wait, let me see. dv dt times step. Okay, so a is, okay, so let's try to do this. So vt plus delta t equals vt plus dv dt times delta t, right? Just a line. And then so we're gonna say v1 equals 0 plus dv dt, which is 80 minus 16v times delta t, which is 0.01. But is that delta v? Three over 1 plus, oh, it is the initial condition. But this is just 0. Oh, I see. I see. v1 equals, that's 0, v0. Oh yeah, I remember this now. Let's see, so 0.01 times 80, 0.8. Is that right? I feel like that's wrong. I feel like that's not right. Oh, it is right, never mind. Okay, so I guess I'll just do v1, v2 equals 0.8 plus 80 minus 16 v1 times 0.01. Let's see if we get that right. I'll do a little matchup at the end. Okay, so 0.8 plus 80 minus, 16 times 0.8. 1.472. Yeah, awesome. 1.47 is good enough. We have to figure out the significant figures with the uncertainty and okay, so that's really not bad at all. Now the only thing we have to figure out is the change in x, which is going to be v, I guess. So we're going to use v. So, oh, I can't do it sideways. Normal. x0 equals 0. xt plus delta t equals xt plus dx dt, which is v. Wait, no, dx dt? Change in x? Yeah, no, that's right. That's right. That's right. Sorry, chat. Oh, I brain farted. I was like, what's smaller than, what's lower level than x? Me when they event. W equals the initial x value 0 plus v0, which is 0 times delta t x1 equals 0, x2 equals 0 plus, and then v. What is v2? V2 is, well, I guess we use v1, 0.8. That would make sense, right? Because that's the change, the latest rate of change we got. This one is after. 0.8 times 0.01? Oh my god. Well, 0.008, is that what that is? Is that right? Let's go. Okay. Awesome. Now we just gotta package it up real nice. So t equals 0.001. Is that right? Yeah, 0.01. x1 equals 0, v1 equals 0.8. t equals 0.02. x2 equals 0.008. v2 equals 1.7447. Is it a little scuffed? Don't worry about it. I just gotta be a little better about that. Oy. There we go. Honestly, kind of winning big time. The last one might not be very good to do, because it's just kind of the same thing. Maybe, let's see. Problem 6. Yeah, the only thing I probably can't do is the space state representation, which I don't know what that is. So, yeah. I mean, I could just look at her notes and get it, but I am... Damie, you're such a tease. You go live on the day I have work and after I used all my breaks. Oh, I'm sorry, Umbra. Well, my next stream is going to be Thursday. And then my next stream is going to be Sunday. So, that's the plan. The Sunday one will be late. The Sunday one will probably be like 4, streaming at 4. It's okay, this was the scuff stream. This was the we're getting back into it stream. I'm gonna set this one up. I'm honestly surprised. This is a dynamics problem set, and I've only been working on it for an hour and a half, and like, I'm made significant headway on it, which is actually very impressive, I think. I mean, like, my old professor's problem sets had like 8 problems, maybe? Closer to 8, but still, like, this is impressive. I have to go crash a class at 6, so I want to take a little bit of a break before then. I don't know, maybe he might just be like, don't come here. And then like and then I can actually do work. But I feel like he's not going to be like that. I feel like he's going to be like, you can stay. I don't know. I don't need to put a given. You literally say the givens in the problem, please. Fine, given f equals 0.12. At least I can... Wait, this is just an equation. Wait, 2 of these are constants. Stop. Why is that true? Why is that? I'm normal. I'm so normal, guys. Why are these problems written like this? At least, like, try to make them harder. I'm gonna, like, hate myself for saying that later. But I feel like I always say that. I'm like, always at the beginning of fluids, I was like, oh, this is so easy. These problems are so easy. I was like, oh, these should get harder. And then they get harder, so. But I don't like it when they just straight up tell you all of this stuff. Okay. Wait, sorry, I need to say find. I don't know, find is so easy. It literally tells you what to find. Find, what is it? Estimate velocity and position. x1, v1. And then space state, but I'm not gonna say that because I'm not solving that. Okay, A. FBD. Moves straight on a frictionless surface. So, drag force acts on the block. Alright, it moves in a straight line, so we have one force going back this way. This is FD. This is V. That's just there. That's not part of the FBD. That's just like as a note. Because right now the block is going to be slowing down, but it just has a speed, so, you know. It's not like there's anything pushing the block. And we'll see the MAD. The KD, I'm going to call it. Because I don't like M. MAD makes it just seem... I don't know, it just makes it seem kind of like... It looks like mad. And KD, kinetic diagram, is very pretty. Kinetic is a good word. Use Newton's second law to find an expression for the acceleration in terms of the velocity. So F equals ma. Oh, I forgot about this. I did this already. F equals ma. What does F equal? F equals cmv. I remember thinking, this is so dumb. Sometimes the answers are just so... Oh wow, A equals CV squared. I did so much work for that. This is giving dynamics right now. Or sorry, fluid mechanics. Fluid dynamics. Alright. Estimate Euler's. So V0 equals... What is V0? 10 meters per second. So then we have V1 equals 10 meters per second plus the acceleration, which is CV squared, so CV squared times time step 0.01. Yeah. I don't know, I can just do that. I feel like that's not really... I'm sorry, chat. That wasn't my mic exploding, that was just me being bad. 0.12. 0.12 times, oops, times 10 squared times 0.01. Wow, 0.012. No way, crazy. Okay. And then... Oh. What? Oh, because it's negative. 10 minus that. 9.988, yep. Yeah, it's not speeding up. 9.99 meters per second. Nobody cares. Nobody cares about that. It's very small. Maybe they do care about it, actually, because it's so small. Fine. Whatever. And then x equals... I guess just 0, and then we can just say that x1 equals 0 plus... Now the v is still going that way, so it's 10 times 0.01. So 0.1, is that right? Wait, 1.0. Oh? Huh? What? Also, why does it say with hand calculation and not MATLAB? Guys, it's like 2 values you plug in. You don't need to use MATLAB to do that. 10 times 0.01 is 0.1. No? Also, wait, 9.88? I got 9.988. Okay, I might have goofed something. Let me try this. Again, CV squared. So C is 0. What? 0.12? 0.12 times 10 squared. This times 0.01 is 0.12. Oh, okay, I was off by so yeah. It's 9.9. 9.88. And then that shouldn't change this though. What? Why is this? This is right. 10 times 0.01. Guys, am I silly? Should that not be 0.1? I think she might, I'm gonna ask her about it. I hope she doesn't have wrong answers on her homework a lot, because she already said she had to fix something on the problem. She's gonna be like, why are you doing problem 6? I haven't taught that yet. And I'm gonna be like, I did it in high school. I'm sorry. We did it for, I don't remember what we did it for. I think it was like something to show that like a derivative is something. I don't know. Alright, I will draft an email. Problem 6 clarification. Answer clarification. It's so scary when like Google will autocomplete their first name in. I'm like, I do not want to email my professor with their first name. Please. Please, Google. Don't do me like this. Man, I need to find a louder Pikmin 3 soundtrack. Alright. Okay. Low-key, that's... Okay, let's do one angular acceleration. Just so I can prove to myself that I still know how to do that. No, not that one, that one's fucked up. This one I can do. Alright, I have to like take an angular acceleration from something already, and then... Oh, I'm not in the headspace for angular acceleration right now. Okay. Maybe I can do the angular acceleration of... No. Oh my god, it's hurting my brain. No, I know what I have to do. Alright, we're just gonna do the exact same process. So we start with VA. So we do AA equals It's a little bit different though. It's not omega cross R. I'm gonna turn that down just a skosh. It's not omega cross R. It is a little more complicated, if I remember correctly. Where is it? 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 Yeah, it's alpha cross R, so let's do this out the proper way. So it's acceleration of O, which is 0, right? We did that? Yep. Plus acceleration of AO cross RA with respect to O, plus omega AO cross omega AO cross, right? So look at that. Cross R A respect to O? Sorry, omega AO. Yeah? What do we think, chat? What do we think? I mean, I think it sucks. It's actually really not that bad. It's just a lot more plugging in stuff. And I think I could do the triple cross product for that, or the triple scalar product maybe, for that third one. I don't exactly remember it, but I think there's a shortcut. So let me just get everything set up, at least, and then I can... Wait a second. Oh no, I'm chilling if I stream till 4:30. Okay, I'll stream till 4:30. I was like... For some reason I thought I had to leave at like... I thought my class was at 5. Oh, I'll stream till 4:30. Then I have like an hour of doing EE. My EE professor asked me to make a cheat sheet of CE, of EE, the other EE I took, electrical engineering, and I was like, can I just send you my VOD? Like, here you go. I taught the whole class in 2 hours, but, you know, pop off. Okay, what was I doing? AA, and then we need the other one. We need it with respect to B, so AA also equals AB plus, which we know, right? We're given? Yeah, we're given. Plus alpha AB, which we want. A with respect to B, plus omega AB cross with omega AB crossed with RA with respect to B. Now this we also did earlier, so we don't have to do that either. That is right here. Right here. Well, it's right here and right here. So this part is chilling, but this part is not. So maybe I do just have to cross it again, but I just use this one. I think I only had to do these two, right? And then I set these equal to each other, and then we pray that the things get out of the way of each other. But I think they do get out of the way of each other, so I guess we into the breach, my friends. Shall I just write it out in one large equation? Do you think she'll hate me if I do that? I mean, it is one large equation. I'm gonna set them equal to each other, so I say we just go for it. I say we full send. Alright, here we go. 0, 0, alpha AO. RA with respect to O. I wrote that down somewhere. That is cos 45, sine 45, 0. And is that 1 meter? I think that's 1 meter, that's why it's... Nope, 0.05. I remember distinctly that I was having issues where I would forget, so I think I'm gonna put them out here. And then plus IJK. Hope everybody likes that. WAO is 0. Wait, 0. It's just 0. Oh shit, I don't even need this. Yes, sickos when I can cross things out. AB. Oh, we have. AB is, what did we say? 0, 1, 0. Plus, fun with this one, IJK 0, 0, alpha AB, RAB, where's RAB at? Right here, 0.1. plus, and now we do this one because we need to, I think. So 0, 0, 20. And then RAB we just said was 0.1, 0, 0. Honestly, not even that bad. Honestly, not even that bad. I say as it doesn't even fit on the screen right here. It's not too bad, it's not too bad. What are we trying to find? I already forgot, it's fine. We'll figure it out. If I do this and this is positive, negative, negative. So negative. Alright. Negative times 0.05 sine 45. And then positive. Wait. Yeah. Don't ask why I did it 2 different ways there. Don't worry about that. Don't worry about that. Don't mind. Then we got another cross product here. This is really confusing. It's fine, it's fine. 0.01 is positive, so I'm gonna do that one. That's gonna be 0.1j. I think professors might be intimidated when I do all these vectors, because I think seeing it as vectors is a lot easier, because I can just like look on the right line. And I mean, obviously I have to get the right, like, obviously I have to write the right letter to get that right, but it's like, it's a lot easier for me, because I'm just like, okay, bam, bam, bam. Right, like 20, it's 20j. So yeah, AO we get is 0. Alpha AO should be 0. Well, I guess it doesn't matter. So basically I don't even need to do anything, I can just say negative 21 equals 0.1 alpha AB. 390 rads per second squared? Hello? What's going on here? I'm getting 210. That's 210. Something's off. Basically what I did is AO is 0, right? Because if we look at the top line, then that's 0. And then I just plugged it into 0, so you get the 21 on the right, and then we move the 21. But the 21 is off. The 20 and the 1 can't be off. Right? That has to be right. So it's probably something up with the AO. Now, is it something up with the... It shouldn't be something up with this angular acceleration. That angular acceleration should be fine. The cross product being 0 should also be fine. Because I was thinking, you know, maybe if we have something here, that could goof it up, but that should be 0 because omega AO is 0. Right, and alpha AO is 0 because it's not moving. So this cross product here, if I do that, then that's the sine, that's the cosine. This is a negative, or this is a positive, and that's a negative, so they get flipped, so negative and positive, that's right, but that shouldn't really be the issue there. It's gotta be some really little thing. Maybe it's just another cross product that I goofed up. Let's see, 0.1, that's positive, it's J, 0K, that's not really an issue, it's J. This one is the exact same thing, except there's a 20 in there. So it should be the same thing there. But it should be 39. So it seems like I'm missing some thing. Something. Is the WAB cross RAB? Where was I doing that? I might have goofed it. That's this. That's this instead. I was taking this one. This is just RAB. So this needs to be not that. This needs to be this. 0 point. So it's not this. This one is correct. This one is not correct. 0, 1.1. WAB. Now WAB, is that 0 or is that 20? That's 20. Okay, so that should give us that extra little bit there. So instead of this, we get negative -20 times 0.1 WAB. And then we get something for that. Shit, I should, like, not cross that out. I keep just... Don't look at my cross products. I can cross it out very lightly. It's just helpful for me to see. I'm a visual guy. I'm a visual learner, please. I know it's like fake or whatever, but... Okay, 0.1 WAB, and then, yeah, it's just 20i, so times 20. Alright, so then we don't get that as 0, we get negative alpha AO equals... I'm gonna get rid of the negatives, 0.1 WAB omega. Maybe if I stopped writing W's and I started writing omegas. I gotta get back into the dynamics mindset. Is 2? Okay. Is that right? 20 times 0.1? Yeah, 10 to 20 is 2, and then 2 times 20 is 40. Okay, okay. Then 0.5 cosine 45 times 40 minus 1. That feels like it could be, right, actually. I'm praying. Uh-oh, actually that cosine 45 does not feel like it's a comfy number, but... What? Oh no, chat, we're cooked. What the fuck? How is it so off? I got 4.1. That's not right. That's not right. What did I do? What did I do? Why is it 0.05? Wait. Oh, because it's not 40. Lol. It's not 40. Wait, but that makes it worse. Uh-oh. I don't know why I just like wrote that. I just didn't write the right thing. Okay. Equals 0.1 omega AB times 20. Well, sorry, 2 omega. I just didn't divide it by anything. 2 omega AB over. Oh no, this is gonna make it huge. Okay, we're chilling. That's gonna make it big. So 40 divided by 0.05. Nice. Yes. Okay, we're chill. We're fine. We're fine. Sine 45. Yeah, that's a really big difference. That's 1131.37 rad per second. You know, compared to 40. Just a little different. Okay, so now we've got... Oh wait, I'm solving for the wrong thing. Lol. AB equals 0.05 cosine 45 times 1131.37. I don't really need all those. I'll put it in, but you know what I mean. 1131 minus 1 divided by 0.1 equals... What do we feel? What do we feel? I feel lucky? I feel lucky. Cosine 45 times this. 40 minus 1, 39. Divided by 0.1, 390 on the dot. 390 on the dot. 390 on the dot. Let's go, baby. Oh my god. Okay, I still got it. I still got it. That one is done. That's just donezo. Bam, put a star next to it. Alright. That was good. Oh my god, we got like at least half of that done. And that was 2 hours? Not even 2 hours. Oh, just 2 hours actually. Oh. Yeah, so I'm gonna stream Thursday, this Thursday. That's the next stream. And we'll probably be doing... Actually, I have no idea what we're doing. Maybe I'll do more dynamics? But like, I might finish it quickly. I might finish it before then. Cause like, we kind of did all like, I mean, I'm gonna be so honest, there's hours of me doing this. There's not really any point. And the EE stuff is like, literally, you can watch the speedrun VOD, and you don't need to watch, I'm gonna rewatch that VOD to make the sheet anyway. I might have thermo, maybe we do thermo. Thermo, oh my god. I went, is classical thermodynamics any, wait, I need to look this up. Is classic thermodynamics the same as continuum fluid mechanics? No. What is the difference between continuum mechanics is the application of classical mechanics to continuous media. Okay, so it is slightly different, because I know we were doing classical continuum mechanics. Because the thing about continuum mechanics is like, it's essentially just saying all of our functions are continuous. Hence, continuum mechanics. And classical mechanics is... I guess... I don't know, what is classical mechanics technically? Let's see. Continuum mechanics is a math course, and classical mechanics is a physics course. Continuum mechanics is a field theory, classical mechanics is a theory of mass points. Classical mechanics is analyze the dynamics of particles or bodies that act like particles. Oh, cool. It's like classic, okay, you have classical mechanics, which is like Newtonian mechanics, and then relativistic mechanics, which is like Einsteinian mechanics. That's what the difference between those are. And then continuum mechanics is a subset of classical mechanics, where we say that all the functions are continuous. Now, maybe we aren't doing continuum thermodynamics. Maybe I'll give him that. But I asked him that and he was like, no, they're not. And I was like, are they the same thing? And he was like, no, they're not the same thing at all. And I don't remember what he said something, and I was like, it's not worth listening to, because he wasn't explaining it right. Because he was talking, I was trying to say, like, is this the continuum hypothesis? Because he was talking about the fact that, like, oh, what is macroscopic versus microscopic? And, you know, when we talk about the continuum hypothesis in fluid mechanics, we talk about the size of a fluid element and how you want to have your fluid element. It's this picture. Where is it? This picture. Picture. So this is when you have a very, very small, too small fluid element, and this is when you have too large of a fluid element, when you're talking about properties, right? But there's a sweet spot here that we actually want our fluid element to have this size of, where if we measure the properties of different fluid elements, and they're going to have the same density, or they're going to have the same whatever, depending, like if the body is actually a single density. Because otherwise you're measuring the densities of like certain areas, and there's like particles leaving, particles coming in. You don't want that. I tried to ask him if it was like this, and then he was like, no, it's not like that. And I was like, okay, Mr. Joker. He also asked what a system was, and I said, oh, a system is an amount of mass, like a defined amount of mass, which technically is a closed system. It's not an open system, but I said, yeah, it's an amount of mass, and it like is in a certain space, because, you know, I'm thinking control volume, I'm thinking like stuff moving across a barrier, right? Mass moving across a barrier, and he was like, no, it's a thing we want to analyze. And I'm like, bruh. Some of us have taken fluids. Thermo is just fluids repackaged, but like, the thing is like, there's a whole 3 lectures on control volumes. I already went through like 7 control volume lectures. Please, King, please. It's gonna be a long quarter, guys. We're gonna throw it back to fluids. I mean, I love fluids, so it's like, I'm not really complaining. I'm just like, I wish he would. His answers were better to questions. I'll just ask my other professor if I have like actual questions. Some of them were just like little things. Oh, I wonder. I mean, I guess one thing I can do. No, I'll do that off stream. I was gonna do like a little review of all of the. I have a lot of asterisks in my notes that say, look up this thing, because my EE professor is not very good either. So, yeah, unfortunately. But yeah, that's that's all for today. See you guys on Thursday. Hope you guys have a good day. Hope you eat some good food, get some good sleep, and I'll see you later. Goodbye. See ya.